Welcome everyone, and I would like to talk about SSH public key authentication vulnerability I found more than a year ago, and I want to document both the journey, what led me discovering and understanding this vulnerability, and both how SSH public key authentication works in general. My name is dnet or András Veres Király, whatever you want to use, and I co-founded a company of hackers, and we try to maintain the biggest and most elite hacker group in the legal hacking team sense in Hungary. And I like to find bugs, find vulnerabilities, and help people make them networks more secure by patching them. And well, let's take time back. We travel back in time. Imagine that it's 2011 and you've been using Git, which is a newer kind of version control, because many people are still saying that Subversion is the king. And yeah, GitHub made Git really popular, but you don't want to put everything online, especially since before the Microsoft sale, they did not offer private repositories for free, but you want to host it yourself. And sure, there was GitLab and Redmine, which could be used as a web interface, and you could configure the system open SSH daemon to offer pushes and pulls over SSH. But the problem is that, first of all, you don't want to mess up your system SSH configuration with Git users, because any misconfiguration could result in security problems. And the other problem is that both of these software, which were popular at the time, were written in Ruby, and managing Ruby is a sysadmin hell. At least it was. Docker solves it. The problem is that it didn't exist back then. And even 2 years later, it was really early stuff. And right now, when you say, oh, you should install GitHub or something, yeah, what we use now, why we like Go software, because it's just a small binary, well, not so small, but at least a single binary that could be just copied on any server. Well, Java offered a similar thing back then, because Go didn't exist yet. So that's why we preferred this thing called gitblit, which was a thing written in Java, and you just had to put a single jar file and start it, and it would also handle SSH, so you don't have to mess up your system SSH daemon, but it would listen on a separate port, and the whole stuff run as a single low-privileged user. So even if somebody messes up, it's still, isolated a bit. That's what we used so that we could have our own Git repositories and manage our stuff that we did not want to publish on the internet. So there was one night I tried to update my repository and I issued git pull. We use YubiKeys, so this prompt came up. Sure, okay, I will enter my PIN, and I entered as I should, because two-factor authentication is good and using hardware is good. And then I got an error message, and then it said, okay, enter your password, because it fell back to password authentication, and I just pressed enter, and it said already up to date. Okay, that's fucked up. Why did it write that? So I just tried SSHing to that same server. And again, I refused the authentication prompt. And then when it asked for a password, I just pressed enter. And it gave me this nice text that if you try to SSH to the Git SSH port, it will say, yeah, you have successfully connected, but you shouldn't use it. There's no shell. You can only use it for Git. So we just managed to bypass authentication as a whole, without actually, using the token to authenticate ourselves. And yet we got access just by pressing enter the authentication. First I thought that, okay, maybe this is just some byproduct, or maybe it's using a previously established connection, so we tried on other machines, and it seems that we found a vulnerability. So to understand what happened, we need to start from the basics. So many people who use SSH figured out somewhere in the first week that, okay, passwords are nice, but we can also use public keys to authenticate. But how do you use public keys to authenticate? Especially since in many cases it can be only used to sign things. So as it turns out, if you read the RFCs, SSH is defined in multiple RFCs. One of them deals with authentication, just authentication. And it says that the client will send a request that, hey, I want to authenticate with a public key, and it sends which username it wants to authenticate with and with which public key. And at this point, the server can say that, okay, I will allow this, or say that, okay, no way, you will not be able to authenticate with this. And when the client receives this, it usually just says, okay, I will try another key, or just fall back to password authentication. But if the server says at step 2 that, okay, you can coming with this key, then the client prepares a challenge, which is just a string of bytes. In some protocols, the server prepares the challenge so that the client cannot cheat. But in case of SSH, it's just a set of rules defined in the RFC. For example, it contains certain bytes from the key exchange, the anonymous key exchange done in the beginning, so that you cannot, for example, man-in-the-middle disconnection, and some other data, and then signs it, sends to the server, and the server does not need to receive the challenge because it can prepare it from the same amount of data. So there is no redundancy, and also there is no way for the client to cheat by altering the challenge. And then the signature is sent and the server can just validate this stuff. So I think it's quite sane and minimalistic. In case of GitBlit, as I mentioned, they didn't use OpenSSH. They used another SSH implementation, and it's called Mina. It's an Apache project. Apache, like the web server, they also serve as a home to many open source projects. And in this case, they created a pure Java library, so there are no native libraries needed. So in pure Java, they have an SSH server, and if you need anything that uses SSH as a transport protocol, like Git, you can just bring this library, implement a few interfaces, and then you're good to go. And our first question was, is this vulnerability in Apache Mina or is this in GitBlit? Because the implications are different, because if it's in Apache Mina, lots of projects might be impacted, although on the other hand, if it would be a problem in Mina, then someone else should have found it by now. So we tried to look into the source code, how it works, and I tried to make this nice little diagram of how it looks like. So we have just a single JVM process, the Java Virtual Machine, and inside there is this SSH daemon, which listens on the TCP socket. The SSH server has its own state machine, and when it reaches a certain step that, okay, now the user is trying to authenticate, it goes to these interfaces that the host application, or in this case GitBlit, implemented, and asks questions like, can this user log on with this public key? And then the application can do its own lookup using its own machinery. And in our case, if we read the Apache Mina documentation, it says that here's this really simple interface. There's this authenticate method, which returns a boolean and takes a string, which username the user tries to log in with, and the public key, which key is trying to use. And then there is this last variable that we're going to talk about later. And then it returns a boolean saying, can this user log in with this key or not? I guess quite simple. But the problem is in the details. So think back to the slide where I described the 4 steps how public key authentication works in SSH. So first the user sends the public key, the server says yes or no, and then the user sends the signature, the client sends the user's signature, and that's when the successful authentication can happen. And this means that this method is actually called twice in these 2 steps, and it has to return true both times so that Mina would accept this authentication. And this would be okay in a programming language like Haskell, where side effects is really tightly controlled. However, Java belongs to the mainstream language group where any kind of function can have side effects, which means that it alters the internal state of the program in other ways than just the return variable, the return value. So even though a function might look like it's just reading stuff, for example, this authenticate method should not alter the state in any way, it should just return a yes or no. Yet the developers of GitBlit decided that for some reason it's good to change the state of our program. So if we go into the source code, you can say that, first of all, it registers this key authenticator, which in this case is the public key manager, and puts a caching layer around it, but the important thing is that we need to trace that this will be the part that is actually involved in this authentication. And then in this SSH key authenticator, it's quite simple. I tried removing the code, that's not really important, so there is this for loop that goes through all the keys and tries to compare equality, and if it finds one and checks whether the user can authenticate with this, which means is this public key assigned to a user, then it will set the user on this client variable and set the key. And what is this client thing? And you can see above, it's gotten from this session, which is the third variable I try to talk about. So the thing is that Mina tries to help developers by offering that they can receive this optional session variable so they can have persistence over several calls. And in this case, they abuse it to store some metadata about the client that is actually connecting to the server. And I'm not sure how many people can read or use a sequence diagram. We learned this stuff at university, but it's not that bad. So here's a legitimate login, how it should work. In this case, there is no bug because code works as intended. So the SSH clients ask, can I log in? Authenticate gets called, it returns true, and although it calls this set user, that's not a problem. It says, okay, continue. And then a well-behaved SSH client who really has the private key to that public key will send the challenge signed. The same authenticate will be called again. It will return true again, obviously. And then Mina will let the user log in. So this is the happy case. The problem is that, as you could see in the video demonstration, if you fail signing the challenge, but you are already past the first call to authenticate, the client decides that it should fall back to password-based authentication, which is implemented by another class, which tries to check if this client object has a user already set. And if so, it will return true before anything else happens. So I did not remove code from this method. This is right at the beginning, so it does no password checking before already returning true in this case. So to see what happens in the internal machinery, it calls setUser here, and when later it tries to check, it will use the same client object. So when it tries to authenticate with any kind of username, it will say, yeah, you can come in, and that's how we could log in the name of any user. And now the question is, how strong is our attacker model? So what do we need to actually exploit this in the wild? So first of all, you need the SSH client to behave like our broken YubiKey authentication. In that case, it was broken because the SSH agent could not sign the challenge. But we could simulate this by only giving the public key to SSH, because SSH is kind of optimistic. So if you set a public key as an identity, it will send it first, even though it has no private key, in the hope that maybe things will work out. So it's a matter of configuring it. You don't need a specially crafted SSH agent for that. And that will first send this request, and authenticate will be called. And libcrypto will give you an error message when it tries to sign the challenge, because there is no private key file. And then you just press enter so that you bypass the password authentication and you're in. Here's a demo. I have here a vulnerable version. And if you go into the repository, you see that it's restricted to be cloned. And if you go into my settings, I am admin, you go to SSH keys, you see that I have an SSH key configured. So as an attacker, you just switch to your terminal and see that the SSH config has the agent disabled, so only a public key is set as the identity file, and that identity file only contains a public key. And now I just try to clone this secrets repository, and it asks for the password, I press enter, and voila, I could clone the repository and get the contents of all the files in there. So it's quite straightforward. But of course, the attacker needs to know the username. This could be usually guessed because it's usually tied to either nicknames or legal names. So it's quite easy to brute force, especially since many SSH implementations don't consider it a problematic info leak if you can get some feedback whether a user exists or not. And the other thing is the public key. It's public, so usually people don't treat it as a kind of secret. For example, raise your hand if you know that you can ask GitHub for any user's public key. Okay, it's less than half, so yeah, you can ask GitHub and it will happily tell you the public keys of users. And many people use the same key pair for everything SSH related. I guess this is the time to realize that, especially not just for some weird vulnerabilities like this, but also for privacy, it's better to just use separate key pairs for every task. And if you use these SK postfix versions, you can just use one cheap WebAuthn token and have an unlimited amount of public-private key pairs, and then you are much harder to correlate between different services. And of course, if you happen to come upon some authorized keys files, they also contain files. So if you either hack the box or you are the rightful admin of one, it's easy to get the user's public keys. And that's all you need to exploit this bug. So to go through what we learned, first of all, it has shown state machines. Many people don't know about state machines because it's usually more related to the electrical engineering curriculum. But in this case, the problem was in the state machine of this git-blitz SSH mina marriage, because although there are some researchers going into state machine hacking, and it's really powerful stuff. Most of them focuses on web-based interactions, and as you can see, there are lots of other protocols that could be just as easily hacked, although you need more than just a burp. The other thing is that integrating stuff is hard, and in security critical code, it's even more important. So it was a sane decision for them to choose Mina over implementing SSH themselves. And if you use a dependency for certain tasks, it creates an abstraction. So you put something in a black box and they say, I don't care about the contents. I have an interface and I'm just using this interface. Yet this is kind of leaky abstraction. If you read Joel Spolsky's nice guide, it has this nice description about that every abstraction is leaky and it's going to bite you in the rear part. And in many cases, it will only cause performance problems. But in this case, it has led to a vulnerability. And you could ask, but why didn't the git-blitz developers look into the implementation and how it works? But they selected an implementation to be used as a dependency exactly because they don't want to deal with this kind of low-level implementation detail. So I'm not saying that they are at blame, yet at the same time, if you read the Apache Mina documentation, that's, you know, technically right, the best kind of right. You cannot say that it's written wrongly, yet it could warn users that please do not make decisions based on how this thing is called. This method should not alter the internal state of your program, just return yes or no. Fortunately, the developers have fixed it at least half a year ago, and 2 weeks ago they released this fixed version, so if you download it now, you already use the fixed version. And I guess not many people use this software right now, so it's on the verge of being abandonware, yet I'm not condemning the maintainers because they still have to, you know, care for their users even though it's not as posh and new as, for example, Git. So yeah, we attackers love these extra features that developers do not care about, exactly because we can exploit them, abuse them, and find nice vulnerabilities like this one. Thank you for your attention. Do you have any questions? Yeah?
Do you track down to see how long this bug was in the software?
That's an excellent question. How long this bug has been in this software? At the best we could see it, it's been there as long as they had public key authentication.
That's hard.
I mean, even we just discovered it by accident, so...
Especially squirrels.
Yeah. The question was if we know how many people actually use this stuff and how many have managed to update to the fixed version. And it's hard. I was thinking about doing some Shodan search or something like that. The problem is that the main use case is that people use this on internal self-hosted Git instances on internal networks. So I would say that maybe those numbers would be even more misleading than giving you real metrics. I would say that some people are using it, but since, for example, it does not have issue tracking and the interface is a bit like the 1990s web aesthetics, I'm saying maybe not too much. So I hope that those users update as soon as they can. The official release notes contains that it fixes a vulnerability, and actually it fixes 2 other vulnerabilities as well that I did not know about. So I guess it's not easy to maintain such old software, and I think there is only one single person maintaining this code base right now. So even though I wrote to an organizational email address, there was one guy answering all the time, and I only saw his name on commits. So it's most likely that it's a bit like abandonware, and too many people are using these centralized cloud providers, so these do not get enough love. Yeah.
So this session context, like where this user thing is stored, like probably it's like you could also go without it, of course.
Yeah.
Do you think like design-wise it should be better if they just omitted this one and don't have any state or don't have to carry the context?
Yeah, the question is about the context. The problem is that if there is just like 1% of the people who have a valid use case for that, I think it's a well-established practice that you give the users, for example, to pass in a logger instance to correlate all these events that happen in a single session. But yes, since it's easy to misuse, I'm not sure.
It's also like with state machine, you have one state and the other state is in the context.
Yeah. And
so it's like shoving around the state. Who carries the state?
yeah, I think more developers should care about the state. So I think I linked here this research paper from the Portsvigger Research Lab, Smashing the State Machine, the True Potential of Web Race Conditions. I also exploited a few of these, and I was really interested when I found one that was not exploitable. So I had the opportunity to talk to the people who actually maintained that software because it was an in-house development. And as it turns out, the guy was an electrical engineer. So he knew about state machines, then designed what states are there and what state transitions are legal, and all others are explicitly forbidden, so I could not exploit. So it's something that might not have received enough love, although I think it's really important, especially in these disconnected front-end, back-end systems where people think that only the legitimate front-end is used to drive the state machine.
And so, like, because like state machines are so easily verifiable, like you can prove stuff really easily.
If you care about security or quality in general, yet many people nowadays don't care about neither quality nor security.
There is another problem with state machines that usually they're just textualized. If you check, for example, mobile standards, they're just like textualized how the state should and which state you go to. There's not really like a graphical state of the state machine. And people implement, like they read the standard, they implement the standard, and you can have multiple implementations for a state machine with different transitions. And it's really hard to implement stuff if you just have a textual representation of the state machine. That's also a thing why I have security problems with implementations.
For example, we had a client who had a two-factor authentication where the legitimate front end said that, okay, send me a two-factor code, and then it also had a check the two-factor code method. But if you didn't call the check method, you could just get into the session. So now you reduce the two factors to one factor. So these things are everywhere, and it's not easy to discover these using automated means. So it's not like SQL map where you start it and it will fuzz it enough to find it. You need to understand how the application works, reverse engineer the state machine of the application, and then try to find those transitions that are interesting.
I mean, sometimes if you actually use a state machine library, you can get out the dot file or whatever, and you can like grab slash proof it, whatever. But even there, the tooling is really like there's not much around the simply.
Yeah,
there's
people.
Like there was like one a library like this where you could like then on the graph like prove stuff. Like, is it possible to go from here to here? No, wait, or something.
Yeah, I guess maybe in safety critical stuff they care about this, but it's just security, not safety. So as long as people don't die directly, they don't care. Any more questions?
One more.
Ah.
You bashed a little bit on GitHub about giving out the public keys. I think your point was, just to clarify, your point was use different public key pairs for different services, because a public key is, as the name says, public.
Yeah.
That was your actual point, right?
Yeah, my actual point was that even though it's public by its nature, people have a hard time saying that, okay, it's public, but what I did not publish it, so no one knows about it. So if you want to calculate how much risk this vulnerability causes, then I think most people's public keys can be really easily found.
So use separate public key pairs for separate services.
Yeah. Okay, thanks. Who's the next?
Thank you.
Thanks.